Let's work on recitation, week 6. So what do we need to do? We need to graph f function, g function. So each one we have f and g as a pair. We need to find the domain of each function. And then we need to find if there is a vertical asymptote or removable singularity. Then we want to compare those two functions. Right. F is easy in a straight line, right? We need 2 points to graph. Maybe we find a good point at the checkpoint. So if x is 0, this is x-axis, this is f of x, and before we call y. Okay? So we see 0, 2, right? 0, 2 on the graph. Then if x is -1, we have 1. We will find 3 points. If x is 1, function value is 3. So let's see, 0, 2 is here. So this is 1 and 2. For x-axis, this is 1. This is -1, right? So if x is 0, function value is 2. F of 0 is 2. If x is -1, f of x is f of -1 is 1. If f is 1, positive 1, then f of 1 is 3. So this is 3. So we have these 3 points. So connect those 3 points. Linear function, right? A straight line as a graph. So what is its domain? So this is a graph. So the domain of a linear function is all real numbers. We write as going from -infinity up to +infinity. And does this have vertical asymptotes? No vertical asymptotes, right? No vertical asymptotes. And no removable singularities. Okay, now let's graph G. Let's figure out the domain first. So this is a rational function, right? The domain is we consider the denominator cannot be 0, which means x cannot be 2. So 2 is not in the domain. But this function can be simplified because the numerator is x plus 2, can be factored as x plus 2 times x minus 2. Then the denominator is just x minus 2. So those two cancel, something divides itself, cancel to be 1. So that becomes x plus 2. So x plus 2, just f of x, right? So after simplification, g is f, but in the beginning it's not, because x minus 2, so the domain is 2 is not in the domain. Right, so that's the first difference. F function domain is every real number, but G, every real number but 2. Now let's graph. So 2 is not in the domain. We also got a couple points, right? We got 0, 1, -2. So we also graph those points. But the only difference is when x equals 2. Let's see, this is 2. What happens when x equals 2? If x equals 2, 2 plus 2, that's 4. So this is a 2. This is a 4. So what if 2 is not in the domain, that normally causes vertical asymptotes, right? Normally in the denominator, so x cannot be 2, normally it becomes a vertical asymptote. However, because x minus 2 divided by x minus 2 is simplified. So it becomes a vertical asymptote, becomes a removable singularity. So this one, no vertical asymptote, but removable singularity at x equals to 2. Right? Removable singularity means this open circle. All right. So now let's graph it. we graph will compare those two graphs, almost the same, right? Except at one point, except at x equal 2. F is a straight line, like continuous everywhere. But at G breaks. So G has this little circle. So the straight line is not continuous at x equals to 2. So that's the difference. So the two functions have different domains, and have different graphs. So it'll be similar for B and for C. Okay, well, let's do B anyway. So the first one, f, is a rational function. Remember when we graph rational function, we think about those two reference graphs. Right? One is 1 over x. We have these two pieces. This is 1 over x reference graph. And then what is this? This is just a horizontal shift to the left 2 units, right? So if 1 over x is here, and the y-axis will be vertical asymptotes, but, oh, let's write down domain. The domain is x not equal to -2. So at the value of -2, that's a vertical asymptotes. So for 1 over x, the y-axis is a vertical asymptote. But for this one, x equals to -2 is a vertical asymptote. Right? Then we know our graph goes this way. Then I have another branch goes this way. For 1 over x, the y-axis is a vertical asymptote. Now let's see G. Well, first let's figure out the domain. The domain is x squared minus 4, cannot be 0. In mathematics, we don't divide by 0. And the difference of two squares can be factored as x minus 2, x plus 2. Solve this. You see x cannot be 2 or -2. Right? But then what happens? The numerator has x minus 2 as a factor. The denominator will have x plus 2 and x minus 2. And those two are the same. X minus 2 divided by x minus 2 is 1. So it becomes 1 over x plus 2. And this is f of x. This is f of x. But the domain is different. So domain for the second one is 2 and -2 not in the domain. Domain for the first one is only -2 not in the domain. So now let's graph this. So at the 2, let's see, this is 2, right? If x is 2, we get a 1 over 4. Let's see, this is 1 over 4. At this point, it's an open circle instead of vertical asymptotes. But we do have, at a -2, we still have vertical asymptotes. Right, so the graph still goes this way. But just at the 2 becomes an open circle. Okay, so comparing those two graphs, we see this piece on the top is a continuous, on the bottom continuous, but this piece on the top at a x value equal to 2 is not continuous. It has a hole here because 2 is not in the domain of the function. But this still has x equals to -2 as a vertical asymptotes. But at x equal 2, we don't have vertical asymptotes anymore because x minus 2 simplify with x minus 2. So it became the vertical asymptote supposed to be now become a removable singularity. So the difference of those two functions, they have different domains, they have different graphs. So let's see C. C See, it's a little bit trouble to graph, but you can always use graphing calculator. All right, when we graph, we consider the reference graph of this one because see x squared. So the graph looks like this, right? Look like this, but we still have a middle piece. Well, but how do we figure out middle piece? Let's see if x is 0. If x is 0, we get f of 0 equals to 1 over -4, right? So let's get a couple points. 0, -1/4. So we get a point here. Now let me try 1. 1 is too small. Let's try 1. If x is 1, we get -1/3. So too close to the previous, right? So 0, -1/4, this one. Now 1, maybe 1 is here. -1/3 is a little bit higher. Hold on. -1/4, right? -1/3. -1/3 is smaller, a little bit lower. Then if x equals -1, same thing, got -1/3, right? That means a little bit lower. So I have two, but this one I have two asymptotes, vertical asymptotes, right? Vertical asymptotes. Okay, let's write down domain actually first. Domain is x not equal to 2 or -2, right? Vertical asymptotes add 2 and -2. So we have vertical asymptotes here. X equals to -2. What is somewhere here? X equals to 2. So the graph goes a downward parabola because it cannot go beyond the vertical asymptotes. So have this graph. Now let's see G. Let's figure out the domain of G. So the denominator can be simplified as x times x squared minus 4, or x minus 4 is x minus 2, x plus 2 again. X minus 2, x plus 2, basically is this. So now you see x divided by x, that becomes 1. Right? But at the beginning, what is the domain? The domain is x cannot be 0, cannot be 2, cannot be -2. So now let's graph this. So after simplification, this is exactly same as f of x. So the graph is very similar to f of x, but only at 0, we have an open circle. Right? We have x equals -2 as a vertical asymptote. X equals to +2. We also have vertical asymptote, right? So the graph, we know 1 over x squared. Oh, actually, I have to shift this a little bit, right? Because x squared minus 2, x squared plus 2. Oh, I already have that, right? So I have this piece. I have this piece. Then I have the middle piece. But this one, x equals 0 is not in the domain, right? So x cannot be 0. So what happens when x is 0? It causes an open circle. Then the rest are the same. So what's the difference between those two functions? They have different domains. The first one domain is all real numbers, but 2 and -2. The second one is all real numbers, but 0, but 2, but -2. And also the graphs are different. The first one, right, no holes, but second one has a hole at x equals to 0. So we want to match those rational functions to the graph. Let's see the first one. The first one is x cubed minus 27, which means can be factored. So this right here. So that means the denominator has x minus 3 as a factor. Then x3 plus 3x plus 9, right? Because 27 is cube, x cubed minus x cubed minus 3 cubed can be factored as x minus 3 times x squared plus 3x plus 9. And the numerator will still have 3x. So we're looking for the asymptotes, vertical asymptotes or vertical asymptotes at x equals 3. Well, let's observe which one has that. At because x minus 3, right? So at x equals 3. Do we see here? Right, we see D. So the first one is D. Now B, the denominator can be factored as factor 3 out as x squared minus 4. Well, x minus square over 4 can be factored as x equal to 2 and negative 2. So now we're looking for the asymptotes at 2 and negative 2. 2 and negative 2. Do we see it here? F. You see at 2 and negative 2, it goes separate ways. So it's F. The 3 can be simplified as x times x squared minus 16. 16 is 4 squared, so that becomes x plus 4, x minus 4. So we need to find 3 vertical asymptotes. 0, 0, 4, and negative 4. Oops, what did I do? Yeah. We need to find 0, negative 4, and positive 4 as a vertical asymptote. 0, negative 4, positive 4. Oh, do you see here? E, right? It's a vertical asymptotes at negative 4, vertical asymptotes at 0, vertical asymptotes at 4. So the E. So 3 is E. Well, let's see 4. I feel like I have done this already. For 4, x squared minus 9 can be break into x minus 3, x plus 3. So we're looking for vertical asymptotes at 3 and negative 3. Oh, yes, A. B, right? You see B has vertical asymptotes at negative 2. And, oh, no, we're not looking for it. We're looking for 3 and negative 3. Yeah, F, right? Oh, no, not F. F is a 2 and negative 2. Oh, here. C. The vertical asymptote at 3 and vertical asymptote at negative 3. So that's C. So 4 is C. Or 5. 5, the denominator can be factored as x minus 4 times x plus 2. So we need to find the vertical asymptotes of x equal to 2, x equal to 4, and x equal to negative 2. X equal to 2 and x equals to negative 2 and 4, right? Yeah, negative 2 and 4. Right, this one, B. Right, you see at x equal to negative 2, vertical asymptotes, at 4, vertical asymptotes. So 5 is B. And last one is only have vertical asymptotes at the -2. At the -2, that's A, right? We say A at the -2, vertical asymptote at the -2. So this one 6 is 8. All right. Yeah, so this one is finished.